This video is about dilution, so we'll start with the concept of what a dilution is. If we say a solution is more dilute than another solution, what it means is if you try to compare what the solutions look like at a molecular level, and it's only possible to do equal volumes, and I represent the solid with dots, then something like this compared to something like this, we'll refer to this as concentrated, and we'll refer to the other one, so more concentrated, as the opposite of that. So the opposite of concentrated is more dilute. So meaning in a certain volume, again we're comparing equal size. In an equal volume of a solution, you look at how many solids or how many moles of solid in there, and you can see that there are more in here than in this one. So when we use the words concentrated and dilute, it's always a comparison. So a solution can only be more concentrated than another, or a solution is more dilute than another. And how can you make a solution more dilute? Well, if you, let's say, take this and put it, I'm going to put it into another piece of equipment called a volumetric flask. So it might only be around this much. And inside, I'm going to use the exact same amount. So 1, 2, 3, 4, 5, 6, 6. 1, 2, 2, 3, 4, 5, 6. So at this point, it's still the same concentration. So let's give this a number. Let's say that the concentration here is 5 moles per liter, which is actually really high. And then in here, let's say it's 10 times more dilute, so it'll be 0.5 moles. So as you can see, it also looks like that the more dilute solution, or in the more dilute solution, the solids are more spread out. So a dilution really means, how do you make the solid more spread out? Well, one way of doing this is to take what you already have and then you add water to it, or add more solvent. So referring back to this, if you take this section of the solution out and you transfer it into another glassware, at this point, because you haven't added more water or solvent to it, the concentration right now is still going to be 5 moles per liter. We haven't added any more solvent to it to make it more spread out, right? They were as crowded here as they were before. Nothing changed. But if you add more solvent to this, then, so same flask, only difference is we're now adding more water to it. If you add more solvent to it, then the same amount of solid, 1, 2, 3, 4, 5, 6, is allowed to now spread out. So as you can see, because they're more spread out, this is a more dilute solution. So this process, adding more solvent to make solids spread out, so that the concentration is lowered, is called a dilution. And in other words, in summary, what a dilution does is it lowers the concentration of a solution by adding more solvent. So why would you want to do that? Why would you want to lower concentration? A lot of times when you buy solutions from a chemical company, we call that a stock solution. It comes in a really high molarity. So something like hydrochloric acid, if you buy a stock solution from a chemical company, will be something like 12 moles per liter, which is extremely dangerous. But it's convenient because a certain volume of it contains a lot of moles of that solute, so you can transfer or you can ship or deliver a lot of moles of the acid, for example, in a small container. Whereas if you dilute it, well, now you might have the same amount of moles. So notice in this example, I still use 6 dots, right? 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. But then you have a large volume to transport, which is inconvenient. So even though this is dangerous, it certainly also gives you flexibility because the dilution allows you to lower the concentration. So if you want, you can now buy that 12 moles per liter stock solution and then add water to it to make it whatever concentration you want, whether it be 0.5 moles per liter, 1 mole per liter, or whatever. But you can't really go backwards. You can only add more water. If you want to go backwards, it's also dangerous, right? So usually we buy a high concentration solution, and then to make it safe to use in a lab or in a reaction, we perform a dilution. So let's look at the exact calculations here. This question is taken from your textbook. Suppose that you're given a solution of 1.25 moles per liter sodium chloride in water, NaCl aqueous dissolved in water. What volume must you dilute it to prepare the following solutions? What volume must you dilute to prepare the following solutions? So picture this. Picture yourself buying this container. And they actually sort of come in a container like this, like a glass bottle. That is 1.25 moles per liter. So that's our concentration. Whenever you see the unit moles per liter, it's a concentration. And you are going to use this to make and whenever you're making a solution, we're going to use one of these flasks called a volumetric flask. You're going to use it to make 50 mils of, so that's our volume, 1 mole per liter solution. So here we have a dilution because you're going from a higher concentration. So you picture this versus this, right? The solid would be more crowded together in this, and the solids would be more spread out in a 1 mole per liter solution. So that means to make this, we are going to take a certain volume of this, right, and we're going to transfer it to here. And then add water to make it 15 mils. Question is, how much are you going to put in there? Well, that depends on how many moles you want. So, one way of doing this is say, okay, I know this is my concentration. I know this is volume I want. What does that mean? How many moles do I want? So we can calculate N equals, so our original equation is this. If you isolate for N equals C times V. Concentration is 1 mole per liter. Volume, you have to change it to liters. So 50 mils is divided by 1,000 to give you 0.05 liters. So that would give us 0.05 moles. That means that we have to transfer from here 0.5 moles. That's how much we need. Okay, to make the solution. But how much of this would give you 0.5 moles? Well, let's go back. And we now know that we need to transfer 0.5 moles. And we're saying that the concentration is 1.25 moles per liter. So in every liter it is 1.25 moles. And if we use this equation, V equals N over C, then we know oh, sorry, 0.05 moles. That's why it doesn't make sense. .05 moles. Over 1.25 moles per liter, that is going to equal to 0.04 liters, which is equal to 40 mils. So if you think about what's happening, we are going to transfer 40 mils to make sure that there are 0.05 moles in here. So after you transfer that 40 mils, you're going to add more water to it to get it up to 50 mils. So if you think about the actual math, 40 mils, you're going to add 10 more mils to it, and that allows this 0.5 moles to spread out a little more. So that's one way of doing it. There is actually an equation that allows you to do this a little more easily. And the equation is based on the fact that the amount of moles here is equal to the amount of moles here. So the amount of moles in our stock solution, I'm going to use N1 to represent that, is equal to the amount of moles that's going to be in our final solution. I'm going to use N2 to represent that. But remembering that N is equal to CV, we can now substitute this into C1V1 equals C2V2. So C1 represents concentration of stock solution. And V1 represents the volume of stock solution that we have to use. Required. And then C2 here represents the concentration of the diluted solution. So what you wanted to make. V2 here represents the volume of the diluted solution you want to make. So think of this as what you want to make. Think of this as how much you need to take from your stock solution. So I'm also going to show you how to do the last question using the same equation. So now that you understand this is actually a long way of doing things. There's a shorter way of doing it using the equation. Right, so I'm actually going to show you how to do the same question using the equation. Okay, so here we have the same question. Okay, and I'm going to label this using variables from the equation. Suppose that you're given a solution of 1.25 moles per liter sodium chloride in water. So this is your stock solution. This is the one you bought or the one you were given. So that means that this is C1. What volume must you dilute to? So this is how much you're going to use of that solution. So this is V1. Actually, I'm going to write this. This is C1. This is V1. So it's asking how much of that you're going to use to make. So when they say to make or to prepare, now you know that this is V2, the volume you want to make, and this is C2, the volume you want to make. So let's bring the equation back. C1V1 equals C2V2, and then we can substitute. So C1, 1.25 moles per liter, times V1 equals C2, 1 mole per liter, V2, 50 mils. Change it to liters. So then V1 is equal to 1 mole per liter times 0.05 liters divided by, move that over, that division, 1.25 moles per liter. And then you will get 0.04 liters, which is 40 mils. So this is just a quick way of doing. Well, here you have two steps. Step 1, step 2. Using this equation allows you to do these two steps in one step, as long as you know what you're doing, right? One more question. A solution is prepared by adding 600 mils of distilled water to 100 mils of 0.15 moles per liter ammonium nitrate. Calculate the molar concentration of the solution. Assume that volume quantities can be added together. So you have trouble thinking about this. This is the original solution you're starting with. So this is like your stock solution, the one you bought. So this is our V1. This is your C1. And be careful with this. This is not the volume of the final solution. This is the amount of water you're adding. So that means that your final solution is going to be 100 mils plus you added 600 mils of water. That is 700 mils. So let's change that into liters, which is 0.7 liters. This is 0.1 liter. And they're asking you to calculate the molar concentration. So that means our question mark here is C2. So we have C1V1 equals C2V2, and C1 is 0.15 moles per liter times our original, you're using 0.1 liter, and then you want to figure out what concentration would be made after you've diluted it to a total volume of 0.7 liters. So meaning you are, if you think about this, 0.1 versus 0.7, this is 7 times as much as that. So basically you're allowing your solute to spread out 7 times more. So so if you allow your solid to spread out 7 times more, that means your concentration should go down by 7 times. That's one way to think of it. So C2 is equal to 0.15 moles per liter times 0.1 liter divided by, we are isolating for this, so we're going to divide that over, 0.7 liters, which is 0.02 1 moles per liter. And here you can sort of see that concept coming into play. All right, when you are dividing 0.1 over 0.7, you're really dividing by 7. So if you think about it, 0.15 divided by 7, because you're allowing your solid to spread out 7 times more, that's going to equal to 0.21. So therefore, the concentration of the diluted solution is 0.021 moles per liter. I know you might have a question about significant digits because these two numbers only have one sig dig, but the textbook actually follows a slightly different rule of significant digits. They, when they put 600 mils, they actually mean 600 decimal. So in a textbook, they are thinking about this as having 3 significant digits. So the number here with the least significant digits is 0.15 with 2 significant digits.